Assalamualaikum warahmatullahi wabarakatuh. My name is Siti SAMSUDIN. Now I will explain about the introduction, which the selected stadium for this study is at University Technical Melaka, Malaysia, which is located at Durian Tunggal, Melaka, Malaysia. UTM will be classified as a space truss because of some design factors. Space trusses are structured having parts that extend in numerous directions and are made to function in 3 dimensions. For this objective for this project is to design the suitable dimension for truss critical tension and compression members, and second, to design the welded connection that been used for UTM study.
My name is NORASHIDAH Binti AZAHARI, and I will explain about the design overview in this project. So this is the simplified layout of UTM Stadium. So this is the front and corner view of UTM Stadium. Truss at UTM Stadium would be classified as a space truss because of some of the design factor. The lifespan of the stadium typically require a large open space to accommodate seating arrangement and sports activities. So this is the simplified layout in AutoCAD. The group member provide the top view, side view, and front view of the UTM Stadium. Next, we move to load computation. The top one is unfavorable, final answer, and the bottom one is favorable, final answer. Based on the calculation between unfavorable and favorable, the biggest result that have critical value was from unfavorable calculation. Next, as for the determination of truss, UTM Stadium have 2 types of truss, which is truss dimension 3/5 and truss dimension AB, such as the isometric drawing. The truss dimension 3/5 in the red box is the truss that our group members select to analyze in this project. Next, and as for the connection type, the group choose to use welded connection in this project. This connection must have benefits and drawbacks that need to consider in this project, such the strength and stiffness element of the truss, the design flexibility, enhanced load distribution, and improved aesthetic value of the truss itself.
Assalamualaikum, my name is HAMIZAH. I will present determination of internal force. For these studies, we use 2 analysis, which is a state-pro software analysis and also manual calculations. Firstly, we calculate load transfer to the truss using a manual calculations, and the load we use in state-pro and also in a manual calculations to determine the internal force. For the state-pro, we transfer all of the load in the truss and also in purlin in the state-pro software data, and we got the analysis just like the figure above. And for the manual calculations, we use a method of joint to determine internal force. These studies, we just analyze truss 3/5, which is renamed as truss 2. Okay, next, after we analyze for both method, which is state-pro method and also manual calculations, we choose the top 5 on maximum load for the compression members and also tension members that acting on the internal members. For compressions members, we choose 5, 6, 8, 9, and also 36. For the tensions members is 17, 26, 23, 18, and 19. So from the comparisons using the state-pro and manual calculations, it just a bit slightly different in the values for both methods. The difference between both methods is not exceeding 2% differences, so it is acceptable. That's all for me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is AMIRUL, and I will continue our group presentation by explaining the design, intention, and compression truss members. So for the first one, we'll go through the design intention truss members. So we chose members 19. So the NAD value as we get from the state-pro is 73.709 kilonewtons. Then for turbo 3.1, we carry out the value of Fy and Fu. Then we propose the initial size. So we calculate the NPLRD. So the proposed size, we look at the SHS table from table of properties. So the value is 40 times 40 times 3 thickness. Then the value of A is 434 mm square. Then we verify the value of NPLRD with the NED. So as we calculate, the NPLRD value is 119.35 kilonewton. So the value of NED is lower than the NPLRD. Therefore, the proposed size is acceptable. Okay, next we will design the critical compression truss members. So we choose member 6. The NED value from step pro is 74.539 kilonewtons. Then we propose the initial size. The size is 673 mm square. Then we find out the classification of cross sections from table 5.2, sheets 1 and sheets 2. The web and flank is considered as class 1. Then we go through the 6.2.4 clause equation 6.10. The NCRD value that we calculate is 185 kilonewton. Therefore, the NED value is lower than the NCRD value. The proposed size is acceptable. Okay, next we proceed with the buckling resistance of member 6. So to calculate the buckling resistance, first we find out the LCR value. So we get 0.9 L. Then from clause 6.3.1.1 we will compress the NED value with the NBRD. So to calculate the NBRD value, we need to find the NCR value, lambda, phi, and also the S value. So the NBRD calculated is 148 kilonewtons. Therefore, the NED value is lower than the NBRD value. The proposed size is also acceptable. That's all from me. Thank you.
Okay, next I will explain about the design of connection, which is the calculations of welded connection. The first one, we assume load is perpendicular on truss member, which is the chosen design force is P equal to 73.709 kilonewton. Truss member length, which is we take from the column to the pointlet, is equal to 545.5 mm. And then we assume the design that we need to choose is square hollow section. Was 200 multiplied by 200 multiplied by 5, and the weld length is we make a welded connection on all sides, which is 4 multiplied by 200, we will get 800 mm, and IZZ we will get 5.333 power of 6 millimeter cube, and then the value of for Fs is 0.09 kilonewton per millimeter. Next, the value of Ft that we get is 0.75 kilonewton per millimeter, and then FWED is equal to 0.76 kilonewton per millimeter. Next, we try size 8 mm of fillet weld, which is the throat thickness that we will get is 5.6 mm. Then we need to calculate the design shear strength of weld, which is we will get FVWD equal to 223 Newton per millimeter square. And then we need to calculate the design resistance of the weld per unit length. We will get FWRD is equal to 1.5 kilonewton per millimeter. So to conclude, FWED 0.76 is less than the FVWDA. FVWDA is equal to 1.25 kilonewton per millimeter, so it's okay. Moreover, this is our sketch of detailing for our connection, which is for the connections. The dimension that we choose is 200 multiplied by 200 multiplied by 5. The distance from the column to the point load is 545.5 mm, and the point load is 73.709 km.
In conclusion, after completing this project, we learn about the calculation of load cases, the determination of internal forces by using step pro and manual calculation, how to find the critical members for compression and tension for this truss calculation. So we also learn about the steps that engineer needs to do to design the stadium by using steel structure. For this stadium, the steel structure are used due to durable and strong elements, which means it can provide the stability and strength to support the load applied on it. It also uses the space truss, which is to create large open stadium with unobstructed views of the fields. The other benefits of using space truss is their lightweight nature. This will make it easier and less costly to transport and install. And for the size proposed for the calculation of critical tension and compression members, I need to select the larger dimension than the value calculated. It is important to ensure that the members for the truss can resist the load applied on it. There will be minor differences between the value that have been calculated using manual calculation and by using the software. It is due to the software will give an accurate value and of the design, while for the manual calculation may be cause of error during the calculation. So that's all.